So this video will be on the beginnings of calculus. And to start off, I want to define calculus and why it was created. It was created to describe how quantities change. It was discovered by Leibniz and by Newton as well. Um, Differentiation is one part of calculus that we study, and it's finding the rate of change of a function. So rate of change. And we have integration, which is for finding a function having a greater rate of change. So greater. And what I basically want to do first, after defining all these three terms, is to show the difference in calculus and algebra and such. First off, what if we have a question that gives us the average velocity of a falling rock, but then it's going to ask for the average velocity given time. So if I have y equals 4.9 t squared m, it can also be written as f of x of that. That's just the same way of, it's a different way of writing it, but the same thing essentially. And so they ask for it during the first 2 seconds. So 2 seconds. Now, this might seem a little familiar, but when we find the average rates and average velocities, we're actually finding the slope of the secant line. A secant line touches a parent line at 2 points, whereas a tangent line crosses only at 1 point, only touches it once. Okay, so that's important for calculus as we find slope of tangent lines in order to find whatever we're looking for, instantaneous velocities. So this is just average velocity though. So we're going to actually find the slope of the secant line. And as you remember, finding a slope of a line is actually rise over run, right? Change in rise over run, yes. And that's how you would normally find the slope. And we also have another formula that we use sometimes. It's called point slope form. Y minus y1 equals m x minus x1. Essentially very important. If you're given the slope and given 1 point, you can actually find the entire equation. So anyway, I digress. So we want to find the average velocity of the falling rock during the first 2 seconds. Like I said, we basically do this: 4.9 times 2 squared, taking from the 2 second, because first we have 2 seconds. What do we have second? They didn't tell us, so it's 0. So minus 4.9 times 0 squared. Really, anything times 0 is 0, so no idea why I did that. 2 minus 0. Okay, so this is going to come out to 9.8. Okay, so we just found the average basically. That's actually the slope of secant line if you wanted to see it graphically. We can also plug in different time values. You have t1, t equals 1, t equals 2, and basically find this from there. You saw what I did correct. This is part of calculus that what I did was I took the 4.9 and the equation and subtracted by the other part of the equation and found the difference below it, 2 minus 0. This is actually how we do find derivatives, and derivative is actually the slope of the tangent line by a similar equation, except I do wish to show an instantaneous question, how to set it up rather than actually do it, but oh well. T equals 1, t equals 2. We have the same function, so but they want the instantaneous. I can't just find the average anymore. I have to take the slope of the tangent line. It's gonna, on a graph, if I had the line of x squared goes kind of like this, quadratic, right? and we have a tangent line. The tangent line is going like this, except it's touching at this point. I can't draw straight. But if we had it again, I can't draw straight. A secant line would go like this, go through these 2 points as you see. But we want this tangent point because with this tangent point, it gets infinitely closer to the point that we're specifying. And then this line kind of turns and you keep going until you get to the point. It's going to be like arrows pointing this way and arrows pointing up this way towards this line, and you will not actually reach that number, but you basically round to it eventually, but it's infinitely closer as it gets to that point. But anyway, so we do a thing called a limit. A limit is basically if I had um like x squared minus 9 divided by x plus 3, and I want the limit, right? Well, x squared minus 9 looks kind of like a quadratic regularly, right? And if I had a limit, it's going to look kind of like I took a little part of it off, because I can't have something that divides by 0, correct? So this bottom can't somehow make it to 0, which means that x cannot equal -3, right? So because that would make this bottom 0, and that makes it undefined, and you can't have that. So this, and there would be like a hole right here, not as big as that, but yes, a hole like that. And then the limit would be from the y value and the x value. You can find that limit. That's just basically graphically how to find it. You can also look at a table of values, and if you see it gets infinitely closer to a certain value, then that's probably the limit. But anyway, I can say that the limit, that is an L by the way, as h approaches 0, that's how you say it, of 4.9 1 plus h squared. Oops. The squared goes on the inside. And then I have minus 4.9 times 1 squared. All over h. H is basically what we did the last time we found 2 minus 0, correct? That's the same as h, basically. And that's basically how you set it up for instantaneous velocity if you wanted to find that. Now let's clear. So let's say algebraically they ask you, what is the limit of, 1 second, the limit of x squared minus 9 over x minus 3. That sounds familiar. As x approaches 3. This is more of an algebraic way to solve it instead of graphically. Graphically is used more often sometimes though. So limit of, as x approaches 3 of the function x squared minus 9, correct, over x minus 3. Now, first intuition, what do we do about this? I see that x squared minus 9. It makes me think dots factoring. So x plus 3, x minus 3, and then x minus 3, right? But we know through factoring that this and this cancel out, right? So we're left with x plus 3, and as the limit limit x approaches 3, basically means that we're going to plug in 3 for that x. So 3 plus 3 equals 6. So the limit of that is equal to 6. So that was basic solving of a limit. And if you ever have something that you can factor, then it gets like that. What if we have something that's the limit as x approaches 3 of 7? Well, the function 7 is a straight line, right? It's saying y equals 7. That would look like a straight line, correct? So The answer to this is going to be 7. It's going to be the same as the function. Um, you can go on and on with this and continually plug in, and then you would keep getting your answers. But if I wanted to find a derivative of something, we're going to have to use an alternative method for this. And in order to find derivatives, what we do is first we need the definition of a derivative. Well, what's a derivative? A derivative is basically the slope of the tangent line at a certain point. So if I wanted to find any derivative at any certain point, I would most likely use this formula, and the derivative notation is this prime kind of symbol of that function x. And by the way, when you take calculus, it's important that you remember your functions. You have your line y equals x as a sort of the regular linear function, correct? You have quadratic, cubic, quartic, whatever you want to use. You have those as functions, and you need to know how to use them, what their domain is, what their range is. You have logarithmic function, you have exponential function, inverse of functions, composition of functions, just basically the making ground of functions is essential for calculus, because how are you going to be able to factor these functions? How are you going to be able to look at them? You need your absolute value function. You know how it looks like a v, and that's basically what you need for that. But essentially, excuse me, essentially for a derivative, it's going to be more something like this. It's going to be the derivative of this as, and then it'll leave a little limit as h approaches 0. And let's say I want to find the derivative of x. Well, I know that a derivative is basically f times x plus h minus f of x, right? You're probably going to ask, well, where does that come from? The reason that we have that is because the basically h is derived as that 2 minus 0 that we had before. The f of x plus h is basically the change in x that we already have, the f of x times the change in x. And the minus f of x, that's minus the function, and that's basically what we apply the limit to. It's basically the rise over run, except in more complex terms, essentially. So if I want to say just x, if I want to find derivative of x, then I know that, well, f of x equals x, right? Because I'm just saying y equals x, it's f of x equals x. It's the same, similar notation, similar meaning, well, same meaning actually. And for this definition, what I can do is, because I have basically just minus f of x, we all know that's going to be x, and we all know that's going to be 1, that f right there, because it doesn't tell me to apply the x unless it's in the parentheses, and the x in the parentheses is already there. So what happens here is that this h and this h cancel out eventually. I know this because they're over the divided symbol, and everything gets divided by this h. But then we're left over with this this x minus this x. Well, we have an issue there. But what's going to happen is this is going to cancel with this, right? And we'll get, well, derivative of x is equal to 1, right? If you plug it into your calculator, y equals x in the y1 slot, and then in the y2 slot plug in 1, you'll see that it should touch it at a tangent line. The more simpler one of a derivative, well, I'm actually running out of time for this one, but basically, when that's just the derivative notation, and limits went over. There are different rules to limits as well that I will go over, but that's basically what calculus is. It's to answer essential questions of how do I get instantaneous velocity. Also can be applied to business aspects. If I have business and extrapolation I need, it can be done that way. Okay, if you have any questions or comments, feel free. That's basically it.